So let's say we have 3.24 grams of glucose, C6H12O6. And we want to know how many glucose molecules we have in this sample. Of course, this first step we've seen a lot of times. We're going to first convert grams to moles. We know that there are 180.156 grams of glucose. I'm just going to abbreviate that with a capital G in 1 mole of glucose. So grams of glucose cancels. We also know that a mole of any substance, including glucose, is equal to an Avogadro's number of particles. In this case, our particles are molecules. And now moles of glucose cancel. So now all I need to do is to simplify this expression. I'm going to multiply 3.24 times Avogadro's number. Now on your calculator, use a parentheses, 6.022, second comma to the 23rd, and then I'm going to divide that number by the molar mass, 180.156. And the result I obtain is 1.08 times 10 to the 22 C6H12O6 molecules. The difference between this problem and the ones we've been doing is this is a two-step conversion rather than a one-step conversion. So let's add a layer of complexity to this. Let's say we have 3.24 grams of glucose, C6H12O6. We can convert this to moles just like we did before. I'm going to abbreviate this as G, just for space considerations. That's equal to 1 mole of glucose. So grams of glucose cancel. I can convert moles to molecules through Avogadro's number. So moles of glucose cancel. And then finally, I know that 1 molecule of glucose has 6 carbon atoms, 12 hydrogen atoms, 6 oxygen atoms. That's a total of 24 atoms. This is also a conversion factor, not one that we've discussed explicitly yet, but one that makes sense to us. And so now all we need to do is simplify this. 3.24 times 6.022 times 10 to the 23rd times 24 divided by 180.156, and I get an answer of 2.60 times 10 to the 23rd atoms of glucose. Now we've done a 3-step conversion. Again, converting from grams to moles allows us then to convert moles to molecules, which then allows us to convert molecules to atoms.